My name is Dr. V.Arulprakasam. I am working at Central Groundwater Board as a geophysicist. Geophysical techniques. What is geophysics? They measure the measurements of the Earth's the various geophysical properties at the Earth surface into the borehole or from the space to know the Earth's surface conditions. Why need the technology? The geophysical technology. Nature and shape of the subsurface region forming aquifer system which control the groundwater potential and recharge system. These are the geophysical methods, gravity methods, magnetic method, SP method, gravity methods, electromagnetic method, VLF, and seismic method, that is a refraction method and the reflection methods. The objectives of geophysical surveys: the delineation of subsurface water bearing zone, identification of fractures in the hard rock area, estimation of overburden thickness and delineation of the bedrock topography, the mapping of aquifer geometry, and delineation of freshwater and saline water interface, the identification of subsurface, identification of suitable areas or locations for rechargeable structures of the groundwater, identification of zones and well designs, and aquifer parameter also we can estimate from our geophysical data. The whatever I told you that geophysical methods, these methods the best tools for the groundwater exploration, that is the electrical resistivity methods. Electrical methods, that is the electrical methods. There are the so many configuration is there, that is the Schlumberger configuration, Werner configuration, and horizontal profiling, that is the radial electrical resistivity survey, and of Schlumberger array and Mislamisa and radial VS. Then the present geophysical survey techniques is that nowadays the people are doing only the resistivity survey, resistivity profiling in lateral, that is the gradient profiling, and Schlumberger profiling also there, and Werner profiling also there, and vertical electrical sounding, and ERT, electrical resistivity topography imaging methods. That is the nowadays the advanced technology for the groundwater. Nowadays everybody is using this ERT methods all over the world, and ground TM also nowadays everybody is using the ground electromagnetic methods. That is also useful for the groundwater. This is the gradient resistivity profiling. Why we are doing the resistivity, the gradient resistivity profiling? That is, if it is the bigger area, we don't know that where we have to drill, where that potential zone is available, we don't know. For that, first we have to trace the area where the fracture is there, where the weaker zone is there. For that, first we have to put electrode. This is the A, this is the B. From middle, suppose this is the 300 meter. This is the 300 meter. This is the middle of the 1/3 of the area. We have to one third of the area we have to scan. That means in 1/3 of the, that means this is the 300 meter. There is a center to 100 meter. You have to fix every P1, P2. From that 5 meter, we have to shift to this side to this side. Then if you are shifting this side to this side, we will get a resistivity, whatever you are getting the resistivity, that resistivity we have to plot in the centimeter graph sheet. If you plot the centimeter graph sheet, you will get this type of curves. This is the your weaker zone and groundwater potential zone. Where we are getting the low resistivity zone, there we have to do the vertical electrical sounding or Werner or Schlumberger, whatever you like, you can do. Apart from this, in the gradient resistivity profiling in the area, it is a single profiling. Then we can do, if it is bigger area, we can do 5 profiling also, one profiling and parallel to that profiling 20 meter 20 meter in the parallel of the center profiling, 20 meter distance we can do the profiling. After that we can make the contour of the area. From that contour of the area where the weaker zone, the low resistivity zone and high resistivity zone we can mark. If it is a low resistivity zone, that area we have to do the vertical electrical sounding. These are the configuration of the Werner configuration. That Werner configuration you got to do in a equal distance, and every reading you got to shift all the 4 electrode in at a time. Another Schlumberger configuration. The Schlumberger configuration, first we got to fix in 0.5 meter, then accordingly we got to put 1.5, 2 meter, 3 meter, 4 meter. We got to shift in the both side. We got to shift 1.5, 2 meter, 3 meter, 4 meter, like that we got to shift. If you are shifting every meter, you are going to penetrate the current like that. If the current will go C1 to C1 and C1 to this current will penetrate like that. Every meter, if you are putting the 1 meter, that 1 meter information you will get. If you are putting the 2 meter, you will get the 2 meter information. If you are putting the 3 meter information you will get. Information means you will get the resistivity of the particular depth. Then we have to plot in this same reading, whatever your interest of the investigation depth. Suppose if you want to investigate 200 meter, just you can both side you have to put 200 meter, 200 meter this side, 200 meter this side. That is C1, C2, you can do 200 meter reading. Then we have to plot in the double log graph sheet. Double log graph sheet. If you are plotting, you will get like that. This reading you will get. And the off Schlumberger also is there, where the space is not there. Suppose the farmer or any householding people, they want to put the borewell in corner of the house, corner of the plot, then we cannot spread the both side. That time what we have to do, that there is the off Schlumberger, the pole dipole, that is called the pole dipole. That is also possible. That is the then the people will ask, if you are doing the off Schlumberger, what is the formula for that? That is, whatever you are taking the reading, that is into 2. The Schlumberger formula is there. The same thing we have to multiply with constant of Schlumberger constant into whatever you are taking the reading into 2. That is your resistivity. That is the interpretation and all. Same what you are doing in that Schlumberger, the same interpretation we can do. This is the resistivity survey. It is based on the Ohm's law. The Ohm's law, that first when you are sending the current, just how much current you are sending, that is it measures the I. From that, what is the difference we are measuring, that is the V. So R is equal to V by I. It is the based on the Ohm's law only. Then when you are plotting in the double log graph sheet, you will get the, this is, if it is the low, this is the your 120 meter, it is the your fracture. This type of, in the field itself, if you are plotting the double log graph sheet, there itself we can see that what is the your overburden and fracture also we can easily find out. This also we conducted survey in 300 meter in Salem district. There we got the very good yield. We put 127 meters drilled, and weathering found that is 6 meter, and the fracture we got is 55 meter and 127 meter. Yield is 14.1 LPS. We got in the Salem district. You see, this is the one fracture, this is the one fracture. We got a fracture. One more is, this is all the Salem district, Chennagiri village. That is also we drilled and so 155 meters, and casing is 12 meter, and fracture, we found 2 fractures, that is 14 meter and 155 meter. Yield is the heavy, high yield 25 LPS. This also we from resistivity survey only. And after the plotting that all the VS data in the graph sheet. Graph sheet means double of graph sheet. Then we have to see that which type of curves, why it is which type of curves. That first one is that field itself, we can see that which depth it is the fracture is there, weathering which depth we can see. But in the same thing, another one, the layer wise you have to show. Layer wise means first what is the first layer, what is the second layer, what is the third layer. What is the first layer of the resistivity? First layer means the topsoil. What is the second layer of the resistivity? What is the third layer of the resistivity? Fourth layer, it is multiple layer will be there. From that we have to see that type of curves. The type of curves, for there is one master curves interpretation. From that, for matching of the curves, we have to see that which type of curves, accordingly we have to match with the master curves. That the first, this one is the this type of curves, it will come to the hard rock area, topsoil, weathering, and massive rock. If it is there, if it is the increasing trend, if it is increasing, that is the hard rock area. Then the K type. The K type is the almost it is the sedimentary, it will get. It is the soil, the again sand, it is the clay. It is the sedimentary area. And this one is the Q type. Q type is always it will get one sedimentary area, and where the salinity is there. Resistivity is the first resistivity from top, it will decrease. That is the salinity area, it will get the coastal area, will get the Q type. And H type you will get the where more overburden is there you will get the H type. That is also hard rock area. The sand, clay, weathering, then hard, there you will get the H type. After that, we can there is one software, that is one interpretation I told, that is master curves interpretation, curve matching techniques I told you that. That is A type, H type, Q type, K type. From that we can curve matching techniques, we can find out the layer, first layer, second layer, third layer. That is one type of interpretation. Another one type of interpretation, that there is IPI2WIN software. From that, whatever you are doing the resistivity survey, that you have to add first you have to, this is the one area. So there are so many ways we can do. From that we got to do the one pseudo section where the fracture is there, which direction it is going, that way. What we got to do, that just we got to put one line. This is the one layer, one VS, this is the one VS, this is the one VS, 1, 2, 3. That software you have to interpret this layer, then this layer we have to, this VS we have to interpret, and the third VS also we have to interpret. So after that, the first open the first VS and add second VS, and third VS also we got to add. If you add this type of pseudo section you will get. From that you see that where this is the your this is the weathering zone. From that resistivity is increasing, again it is increasing, it is giving that it is the high resistivity, then it is a high resistivity, in between there is the low resistivity zone, it is the fracture zone. Another one is the, afterwards it is the increasing. It is the curve district, it is also we got the high yield. Then you put around 10 meter you put casing. Casing means that you found that weathering, up to weathering you put the casing. This also for we did for groundwater exploitation. Another one is this, the curve district. This is also same IPI2WIN software where we did the interpretation. There also we added the 3 VS. From that also we found the weathering zone and massive. This is the one fracture also we got it. It is the one weathering is also. We also here also we drilled up to 200 meter. We got the good yield. Another one is the first And previous slide I told you that there is the radial electrical sounding. This is a radial electrical sounding is to find out the orientation of the fracture. You know how to do the vessel in keeping one place. Suppose this is the center. First you have to do one VS, then perpendicular one VS. Suppose it is the north, it is east west one VS, east west, then north south one VS, then one VS, then one VS, north west, the northeast, southwest, northwest, east, south east. That way we got to do. Whatever you are taking, there are 4 sets of reading is there. That reading we have to plot it in the centimeter. Is that plot it in the centimeter graph sheet? Then you will get this type of your conical. So this is the your orientation of the fracture. Suppose in the former, after putting the bore well, they may ask, sir, already you people are drilled here, sir, I want to one more bore, I want to drill, which direction I can put. So that this type of survey, it will purpose of it will solve that their purpose. Then this is also one more radial electrical sounding. This was a missile Maivadi Chalai in Pudukottai, where did the multiple fracture we got it. Here also we got the 14 LPS we got this area. And one more conductance method. This is already 2 interpretation I told that one is curve matching techniques and IPI2 in software, and is now we are doing the conductance method. Whatever you are taking the reading, rho value you are taking the from field from AB by to rho A. If you did wherever the high conductance is there, this is the your wherever the high conductance is there, that is the your potential zone. This is also we can field itself, we can interpret, we can give the site also. This is, you see that this is the resistivity curves. For seeing the resistivity curves, there is no indication of the fracture, whereas we are seeing here, this is the your fracture. This is your fracture, you can see. This is also one fracture. Your conductance zones, we can easily interpret easily. We can give the site also. That is also inverse. That is what I told that conductors was nothing but inverse slope method. For this also inverse slope slope method also we can decipher the first layer, second layer, third layer. This also we can find out. There is one software, inverse slope method software is there. From that software we can find out the thickness of the layers and the resistivity of the individual layers we can find out. And one more, whatever I told that it is a electrical resistivity method. So far you have seen. Another, it is advanced method for ERT, for imaging techniques method is there. From this we can put continuous every 10 meter we can put the electrode. How many electrode you are putting, that much depth of information you will get. If you are putting the 108, 128, if it is increasing your, if you are increasing your electrode, so that you will get the more information of subsurface formation. So this type of you will get this type of, I will show you next get it. In the parallel if you are doing that, and 3D interpreter also, 3D figure also you will get like that. You see, if you are doing, this is the single profiling. If you are doing the single profiling, you will get this type of interpretation. If you are doing the multiple in the parallel line, you will get this type of 3D figure you will get. This is the ERT method. The another advanced method is ground term survey. It is a ground TM electromagnetic method. It is nowadays the people are doing it is the imaging and electromagnetic method. The both methods are advanced method. Everybody is doing this one, and this also first we have to put one. First we have to put one rectangle wires. This is the transmitter. Then another one is one thing we have to put the this is the receiver. Just you have to put you have to send the current through this current through this. From this you have to receive from the first primary current. It will go through this. The secondary current will come through the inner loop, so that you will get the information from the center of the loop. If you get like that, just you see that the figure, the same loop they are carrying that and Elibon survey also. You see, this it is the same, whatever you have shown, that whatever you have drawn that loop, the same loop, it is a ground term. This is the same term, it is the carrying to helicopter, it is carrying the same loop, it is flying like that, it will fly like that, again it will go like that, again it will go like that, again it will go that, again it will go like that, again go like this, it will go like that. So, there are so many track it will take. So, the bigger area, the easily it will trace. This one is only the one in grounding. One particular area we can put in, we can 10 meter or whatever space is there, accordingly first loop and the second loop you can shift to the 5 meters or 10 meters, the third loop you can shift to 5 meters or 10 meters, just like if you are shifting this type of pseudo section you will get. So, from that you see the top is saline formation, then is the weathering, that is the massive. This type of in Palo quantity, this type of imaging you will get. After getting this one, we go to process the our data to convert to the resistivity, and then one more software is IX1D. From IX1D we go to export to IX1D software. From there we have to interpret the layer. That that software, it will give the first layer resistivity, second layer resistivity, third layer resistivity. Whatever layer is there, that individual resistivity also you will get, individual thickness also get, the total depth also you will get. This type of curves you will get the resistivity versus depth also you will get. This type of this also you will get. This is also in that is the coastal area. This is also coastal area only, but there is no saline, but only weathering you will get. Then there is one fracture also we got. Then massive also we got from ground temp. This is the high temp. What I told you in the previous slide. The same thing. Same thing. It is the receiver. This is the receiver. This is the transmitter. This is the loop. This is the one loop. What the ground temp is doing is the same thing. It will carry. It will try. It will fly. Accordingly, we will get the reading. After that, we got to process with our software. Then we will get the 3D and 2D diagram you will get like that. This is the primary magnetic field and secondary magnetic. Then whatever you have seen, that is the geophysical method. Now we are going to see that about. This is the in I don't know India. In Tamil Nadu, every water divining people are having that water divining instrument. There are so many water divining instruments are came. That is the one of the instrument is the PKWT. This PKWT is there is the two, they are provided two electrode, one bumped up like they are given from that electrode. First what we have to do, that this is the 0, this is the 10 meter, 0, this is the 10 meter. Just to one electrode should be here, one electrode should be here. Just we have to take reading. Then we got to shift to 1 meter. This is 11 meter. This is 1 meter. Then we go to 2 meter. First reading, second reading, and this is 12 meter. Then 13 meter. This is 3 meter. This is the 13 meter. that center of the investigation is also it will shift, center of the information also shift. When you are shifting that your electrodes, your center of the information will shift. Afterwards you will get this type of image, you will get from that image wherever that this type of block and blue wherever you are getting, that is the fracture. This is fracture. This is the fracture. From that also we can easily identify, we can easily within this within it is within half an hour we can find out the this survey. This also we are and all water divining people are using this one. The one more is that geophonics instrument. There is one instrument, geophonics instrument. This is one geophonics instrument. There is a two type of geophonics instrument. One is the grounding geophonics instrument and the long range geophonics instrument. The grounding geophonics instrument is first we got to put one. This is just like what you are doing in the electromagnetic. The same funda it is there. It is the receiver. It is the transmitter. Just one receiver, one transmitter should be kept in far away. Far away means that is you put it the 30 meter. That 30 meter or 20 meter or 30 meter or whatever you like, whatever your information is required, whatever your area is there, accordingly we can put it. Wherever if you are keeping the less distance, you will get the accuracy is more. If you are putting the put 30 meters, then that that WAM top is there, that or your that software you can install your mobile. From that mobile, just you got to link with your mobile to this instrument. For that mobile itself, you can see the how much distance is required, investigation is required, what is the distance you have put the receiver and transmitter. Accordingly, they will give the reading, this type of. After that, finally, after 10 minutes, you will get this type of figures, you will get this type of figures. From that, we can see that this type of figures you will get where that also where that this is the fracture, this is also fracture, this is also fracture, this type, this is also fracture, this is also fracture. This type of fracture you will get within 30 meter horizontal, 300 meter depth. Easily you can find out within 10 minutes it will trace, it will give your subsurface formation where the fracture is there, where the massive is there, where the weathering zone is there, it will give within 10 minutes you will get that. From the geophonics, grounding geophonics. This also you can see the fracture, this is also from grounding geophonics only, this is also grounding geophonics, this is also grounding geophonics. You see from grounding geophonics you will get the multiple fractures. This also you see that what is the yield 14.1 1 LPS we got. There is a two sets of fracture is there, 15 meter and 127.1 meter fracture is there. That whatever I told that previously I told that is the grounding geophonics. The one more jet detect one instrument is there. If you are carrying this instrument, it will rotate. Wherever it is rotated, there is a groundwater potential is there. It will give, it will not give that where the fracture depth, it will not give, it will not show in your computer. But this one more is there, geophonics long range. In the geophonics long range, it will show your where the depth, the jet tech only they rotate where the zone is there, weaker zone is there. But it will not give the long range geophonics, it will go where the depth, what is the depth of the fracture. It will give interpretation also, it will go from this geophonics long range instrument. In in the jet tech, it will not give interpretation and all. Wherever they are rotating, there we have to do other geophysics geophysical survey or peak WD meter we got to do, then we got to find out the depth of the fractures. Whereas this one, that this instrument itself, it will give the fracture depth of the fracture. You see, this is geophonics long range, it will give the where that fracture is there. This is the geophonics long range. This is during the actual drilling, our depth of the weathering up to 6 meter weathering you got it. Up to that, up to 6 meter you put the casing, and there is 180 meter you got one fracture, and 250 meter also we got the one fracture. This is two sets of fracture we got from geophonics. Then the same wherever we did the geophonics, there we did the our electrical resistivity survey of vertical electrical sounding. There we did, we identified, we correlated with our data, VS data with geophonics long range data. We correlated. It is almost, it is matching. You see, this is also through geophonics long range. You see, there are the three sets of fracture you got it. Same thing, this is the weathering up to 12 meter. Up to the 12 meter you put the casing. Afterwards, the fracture, three sets of fracture we got. There is one fracture is around 72 meters, one fracture. 72, this is 72 meters, another 94 meter also we got the fracture, 108 also we got the fracture. You see, here also one fracture, but up to, they drilled up to 200 meter, they got the, it is also very good yield. Tirupur district, 3 LPS something else they got it. One more instrument is ADMT-300S. Single channel groundwater detector. It is the, why it is 300S single channel groundwater detector. That means 300 meter information. It is a 300 meter investigation instrument, and 500 meter also is there, 200 meter also there, in different depth meter is there. So it is the ADMT 300 meter single channel. Single channel means you will get this type of only one only 2D image only you will get. If you are giving that multiple channel, if you are using the multiple channel, you will get the multiple channel, you will get the 3D imaging you will get. Single channel groundwater information. This type of figures you will get. This miscellaneous survey we can do where that limestone is there, that limestone area we can do this miscellaneous area. How to do this miscellaneous area? Suppose this is the your borewell, there you got the cavity, that you got to put one electrode, or C1 should be in here, and one electrode should be somewhere here. This is the C2, then the borewell, the P1, P2, this is the borewell, in the borewell, that the both side of the borewell, the P1, P2, we got to shift this direction P1, P2, this direction P1, P2, this direction, just we have to shift, that you have to take the reading, so that after taking the reading, just you have to plot it to the centimeter graph sheet. So where that habit is going, there we can, so this the conical or like that, it will show which direction it will go, which direction it is going, over that orientation we can find out from that miscellaneous survey. That is useful for in where the cavity is there, that area, this miscellaneous method is the useful. The another one is the where that, suppose that what I told, that the radial VS, instead of the radial VS, after putting the borewell, wherever you got the fracture, that area also we can do this miscellaneous method. So that orientation of the fracture you can easily find out.